factor out the GCF from the polynomial. The polynomial 18y cubed minus 6y squared plus 8y. Now when we are asked to factor out a GCF, first it's best to understand that the term GCF stands for greatest common factor. The greatest common factor. First we need to find what the greatest common factor is across all of the terms in this polynomial. The way we find the greatest common factor, the GCF, is we work these letters backwards. We're going to work from right to left. First, to find the GCF, we're going to create a factor tree for each term in our polynomial. We're going to create 3 factor trees. Inside, across all those factor trees, we're going to look for common factors. We're going to identify all the factors that are in common across all the 3 factor trees that we're going to create. But we're also going to look for common factors the greatest number of times that they may appear. So let's take these steps in order. And the first thing that we're going to want to do is create our factor trees for each term. First thing I do when I factor a term is I give the number its own branch of the factor tree and the variable its own branch. And we continue on the number. You know, this could be 2 times 9, it could be 3 times 6, it won't matter, because in the end of that number progression we're going to have 2 and 2 3s. 4 small exponents on variables. This technique I'm going to show you for the variable branch works just fine. There are more efficient methods than this, but I'm more concerned that you get the correct answer. We're on to the next term. I'm going to disregard the signs. I'm going to treat each of these terms as if they're positive for the time being. We are multiplying 2 times 3, to make the 6. The y squared becomes a y times y. Move on to the last term, 8 times y. The 8 is composite number that breaks into 2 times 4 times y. The 2 is prime, but the 4 is composite. It breaks up into an additional 2 times 2. And there we have all the factor trees are complete. The next thing we're going to do now that we've completed the factor trees is we're going to identify the factors that are in common. Here comes this step. We're looking for common factors. Now in this case, we are actually ready to say, declare what are the components inside the GCF as soon as we get to common factors, because the CF in GCF stands for common factors. We're ready to list them out. Only the factors that are in common between all 3 across all 3 of the terms. Now there's a 2 that I can match up to a 2 in each of the other 2 factor trees. For every match all the way across, we list one of those 2's. We move on to 3, but I only see 3 in this first factor tree and the second factor tree, but I don't find a 3 in the third factor tree. That is not a common factor. 3 is not a common factor across all 3 terms, so we do not write it in as a common factor for the GCF. We move on to y's, are the next different kind of factor, and I do see them involved in the factor trees of each of the 3 terms. Y is in the first tree, the second tree, and the third tree. For all that match, we list y as a common factor. There are no other common factors that I can identify in this polynomial. Now, so therefore we've identified this as the greatest common factor. We listed every unique factor out as many times as we were able to identify them in common. Common factors can be positive or negative. This means that the GCF could be negative 2y or the GCF could be used as a positive 2y. Now let's move on to the next part of this. Now we found what the GCF is. Now we need to factor it out of the polynomial. So let me switch back to our black pen. Here is 18y cubed minus 6y squared plus 8y. This is the original polynomial that we're being asked to factor out the GCF. Here's our GCF. I'm going to start the GCF as the positive 2y just to get started. I'm opening up an empty set of parentheses right underneath the original polynomial that we're being asked to factor. Now, if the GCF is being factored out of 3 terms, we open up 3 blanks, one for each of these original 3 terms. And now our job is meant to fill in each of these 3 blanks with everything we need so that this GCF times this blank, whatever we put into it, makes this original first term come back. Now, it's helpful to have the first term for future factoring. It's helpful to always leave the first term of this remaining polynomial to be positive. Now, if we force this to be positive, which we want to do, and to get back this original 18y to the third, which is positive, here's the decision mark, the decision step as to should I use the negative GCF or should I use the positive GCF. And in this case, a positive times something to make a positive would have to be, this GCF has to be positive. So there's the selection between the negative version or the positive version of the GCF. Now we fill in all the other components. Positive times positive makes positive. Good. 2 times, I need a 9 here to make 18. Y to the first would require a y to the second, so that the product rule, when we multiply exponential expressions that have the same base, both y, we would add exponents. 1 plus 2 makes 3. So we've got everything we need in this blank to make the first term come back. Now we distribute the GCF to the middle and put everything else we need in here. Signs, numbers, and variables. Everything we need to make negative 6y squared come back. Positive times, this would have to be negative. Positive times negative to make negative. For the number, 2 times, I'd need a 3 here, so that 2 times 3 makes 6. Y to the first would require a y to the first, so that y to the first times y to the first makes y to the second. Just like we did y to the first times y to the second to make y to the third in the first term. Now, we're going to distribute the GCF to this last blank and fill in everything we need. Positive times positive makes this positive. 2 times, I would need a 4 here to make 8. And y to the first, I don't need any more y's here because we've already got y to the first in the GCF itself. So I think we're down to what we need. The final answer should have the look of 2y as the GCF factored out, and with the remaining polynomial 9y squared minus 3y plus 4. Then we'll go up to our answer choices and see if we can identify this answer. 2y, many of the answer choices look similar, but it appears that B is the correct answer choice because it looks like it has all the proper components. 2y, I'm just checking it, 9y squared minus 3y plus 4.